Welcome back to the Anatomy channel. Today, you're going to see a lot of fun, science, and chemistry, and a little bit of cat mixed into a fun video. So with the help of my siblings, Hannah and David. Hi Hannah. Hannah's a little bit camera shy, so Hannah doesn't want to talk. But David isn't camera shy. Yeah. Say hi. Hi.
So also, if you did not know that what is the difference, because the younger Handyman channel and David, and I post the younger Handyman channel videos.
But here, what I was talking about. So using the fun science experiments, we're going to be cleaning our grandma's tarnished jewelry. So I'm going to show you what it means as jewelry is tarnished. Now, if you can see, David has a chain, and it's also sterling silver. I bet a lot of this is silver too. Some of this might be 90%, some of this is 100% pure. But that's newer than this. Some of this is almost pure black. Some of this is slightly less black, but still, all quite tarnished. You might be asking for the rocks. Nothing's going to happen to them. That's just the jewelry, how it is. Now this I suspect is probably not silver, but we'll put it in there anyway, since it could be silver. Maybe it's all the tarnishing.
This is how real silver looks when it's not tarnished.
So before I actually get to the experiment, I want to show the science of it. And while I'm doing the science, I am going to ask my cat, and I know, keep him here, to keep you guys entertained. I hope he wants to sniff. He wants to stay here. So, using chemistry on silver tarnish. And this is only meant for silver, by the way. So over time, silver tarnishes, it turns dark. If it's allowed to continue long enough, it will turn black, kind of like the symbols, or whatever this is supposed to be. The ugly tarnish that we see on silver is actually the result of a chemical reaction between silver and sulfur-containing substances in the air. The ugly tarnish that we see on silver is the result of a chemical reaction between the silver and sulfur-containing substances in the air. The silver is actually combining with sulfur and forming silver sulfide. Silver sulfide is black. If a thin coating of silver sulfide forms a surface in the silver, it darkens the silver. This is why we call it tarnish. But wait, science will come to the rescue. But let me tell you something quickly before I continue to the next paragraph. So, you might be asking, why is a lot of this not black? The coating is super thin, and there's not enough tarnish on it yet that will turn it black. But if you have enough tarnish, it will turn black. So there's two ways to remove tarnish or silver sulfide. One way is to strip it from the surface of a polishing compound. So there's actually a video where I polished it, but that's not with silver. That's with a copper coin or a bronze coin. I'm not sure. It's a coin. I can show you later. Or up there or up there. I don't know why I'm making it, but you'll find it in one of those two corners. But anyway. So if you want to polish it, I would recommend that because... So the first one is again polishing, and it will finish is that it will remove a small amount of the material. The other method is that we'll focus on here. So to reverse the chemical reaction between silver sulfide back into silver. Polishes that contain abrasive shine the silver by rubbing off the silver sulfide, but also some of the silver along with it. So that's why I'm saying you shouldn't polish it. Obviously, the better way to do any with the tarnish is to reverse the reaction by creating in the first place and save your silver. This is something that is easy to do at home with commonly found items. And now for real science, or for the real science. As I previously mentioned, the tarnish removal method uses a chemical reaction to convert silver sulfide black back to silver. Many metals, in addition to silver, form compounds with sulfur. Some of them have greater affinity for sulfur. Some of them have greater affinity for sulfur than silver does. Affinity is basically what a compound likes another. Like, say, paper. If you put water on paper, the paper will get wet, which means the paper absorbs it. Say you get something else, like say there's a granite table, it will repel it, so it won't absorb it. So that means it has the lower affinity. Really. This is for different things, not just for tarnish. Aluminum is one of them, and luckily most people already have lots of it in convenient to use form in their kitchens. In this case, silver sulfide reacts with aluminum. In this reaction, sulfur atoms are transformed from silver to aluminum, freeing the silver metal and forming aluminum sulfide. Chemists repeat this reaction with a chemical equation. 3Ag2S. Ag2S is silver sulfide, so Ag is just silver, and then S stands for sulfur. 2 is for 2 atoms. And then there's 2Al, which probably means 2 aluminum atoms. And then there's arrows, which probably means it turns into 6Ag, which probably means 6 silver atoms. And then there's also aluminum sulfide. So Al for aluminum, 2 atoms, and then I guess 3 electrons. In case you don't know, this practically means that silver sulfide, which is known as tarnish, if you add tin foil, now explain, and there's other ingredients like salt and baking soda. You don't have to have ionized, it just is ionized right now. I don't know why it's ionized or not, but it does not matter. So, in terms that everyone can understand, so what I'm basically saying was that silver sulfide is, if you add aluminum foil and salt and baking soda, I'll explain what they're for later, and you'll see why. And then you will get pure silver and aluminum sulfide. So the aluminum foil, you don't really need to keep after the experiment, but that's pretty obvious. So the reaction between silver sulfide and aluminum takes place when the two are in contact while they are immersed in baking soda solution. As with almost all chemical reactions, the reaction is faster when the solution is warm. The solution carries the sulfur from silver to aluminum. The aluminum sulfide may adhere to the aluminum foil and may be found floating in the water, having detangled or detached from the foil, or it may form tiny pale yellow flakes in the bottom of the pan. The silver and aluminum may be in contact with each other. Because of a small electric current flows through between them during the reaction. This type of reaction, which involves an electric current, is called an electrical chemical reaction. Reactions of this type are used in batteries to produce electricity. Hopefully, this little bit of science will make your future holiday preparations faster and easier, not to mention saving your silver to be enjoyed for many years to come. Silver tarnishes in air to form a black coating of silver sulfide, but let's read the chemical equation, which has the formula of Ag2S. Information of silver tarnish following the reaction with hydrogen sulfide H2S as it follows. There's speculation in that in the present day, the tarnishing of silver actually occurs more quickly due to the increased amounts of hydrogen sulfide released into the atmosphere by the combustion of fossil fuels like gasoline factories and power plant and stuff that produces carbon dioxide. They also could make the gas, which we like to call hydrogen sulfide. That's, I guess, what happens when you burn CO2 too. This silver sulfide tarnish can quite easily be removed using polishes that contain abrasives to rub off the silver sulfide. The silver sulfide tarnish can quite easily be removed using polishes that contain abrasives to rub off the silver sulfide. But those who have a disadvantage of also removing small amounts of silver. Hardly, chemistry provides a method with side steps to this problem. Because I bet you don't want to lose small amounts of silver. Silver is a precious metal. Not as precious as gold, but still. It's about $20 per ounce as of making this video. Maybe more or less. Like during COVID, the prices were higher. But that's not what matters. The simple method merely uses aluminum foil, boiling water, bicarbonate of soda, which is basically baking soda, and the 2 spoons of baking soda, and our sprinkling of salt. Then just add boiling water. The tarnished silver object, which in this case jewelry, to be placed into the water, making sure that there's contact between it and the aluminum foil. And the silver sulfide tarnish will swiftly disappear. The chemistry behind this reaction is relatively simple because it's probably difficult to find the full equation online. And salt, sodium chloride, like we guys did in the pool video when we added the pool salt. So line bowl with the foil and add a 2 spoons of soda bicarbonate of soda, which means baking soda, and a sprinkling of salt, which means a small amount of salt. And then just add boiling water. And the tarnished silver jewelry then will be placed into water, making sure there's contact between it and the aluminum foil. And the silver sulfide tarnish will swiftly disappear. And then the chemistry behind this reaction is relatively simple, but it's surprisingly difficult to find a full explanation online. This fully describes the chemical reaction occurring and the reasons for the inclusion of the baking soda and salt. So this is my attempt to address that. Aluminum has a strong affinity, which, as you might recall, means the chemical wants to bond with a different chemical each other. So let's go back again. Aluminum has a stronger affinity for sulfur than silver, which means the silver would rather go to the aluminum than silver when given the choice. It's never giving it the choice. So in this reaction, the aluminum simply displaces the silver from the silver sulfide compound to free the silver metal from the aluminum sulfide compound. So 3Ag, 2S, and then there's an S and an asterisk, plus 2A, and then there's an S and an asterisk. And then it turns into 6Ag plus Al2 3E, and there's an S. So that's the chemical reaction. And remember, Ag means silver, and Al means aluminum. So what this basically means in English terms is 3 molecules of silver, 2 molecules of silver sulfide, plus 2 molecules of aluminum, and then it turns into 6 molecules of pure silver plus aluminum sulfide. So what basically happens is the charge goes from silver and goes to aluminum. Like, you know when you get a lot of mosquitoes and then someone who is more attracted to mosquitoes, then mosquitoes go to that person? This is basically that thing, this same example, but in smaller terms. So let's get started. I probably talked for like now 5 or 10 minutes. I don't know, because I'm still actually live and I don't know how much time I actually made in the video, how much didn't. But the reaction itself is actually an electrochemical reaction. Essentially, a tiny electric current flows between the silver and the aluminum when they are in contact. And the silver in silver sulfide is reduced, gains electrons to form silver metal, whilst aluminum is oxidized, loses electrons to form aluminum 3 plus ions. So 3 molecules of silver, and if you add 3 electrons, you will get 3 molecules of silver. So now it's 3 silver ions plus 3 silver electrons gets 3 silver molecules. And I bet you know what ions and electrons are. And because all this is taking a while, I think you know, so I'm gonna let you do that part. And then aluminum will turn into aluminum 3 plus ions plus 3 electrons. Combining these 2 half equations gives us the full redox equation for the reaction. Redox means reducing oxidation. Reduction oxidation. So diagram tells me that. So it's showing me that aluminum plus 3 silver ions will turn into aluminum 3 plus ions plus 3 silver molecules. This explanation is fine, but it doesn't explain the need for the bicarbonate of soda or the salt during the reaction. And both are vital components. So then aluminum 2s3. So this explanation is fine, but doesn't explain the need for bicarbonate of soda, which is baking soda, during the reaction, and are both vital ingredients. The sodium bicarbonate, which is baking soda, is required to. This is actually baking soda. I thought this is baking soda. This is salt. So the baking soda is required to remove the thin layer of aluminum hydroxide that forms in the aluminum foil. Without this, the reaction would be unable to obtain a ready supply of aluminum ions, and such as could not proceed. The reaction between these two also produces hydrogen, which plays a part in the removal of silver tarnish, and is just given off as a gas. The salt, meanwhile, acts as a salt bridge. This aids in the transfer of electrons in the reaction process, preventing the imbalance in charge and allowing the oxidation and reduction reactions to proceed. You might also notice a faint aroma of raw eggs while carrying out this procedure. This is due to further reactions that can odor. Aluminum sulfide can go on to react with water as follows. A2S3S plus 6H2O, and there's I in parentheses, into 2AlOH3AQ plus H2S, G in parentheses. There's also other things that didn't put in parentheses. Hydrogen sulfide, H2S, is actually the same gas that rotten eggs give off, hence the smell. So you may want to. So you don't have to, but you want one of those things, those wood things that pinch noses. But anyway, let's get to the experiment, because we finished with all the science part, and this did take a while. So first thing we need to do is we need to get some foil. We have to line it from about here to here for our size bowl. And be careful, some have sharp edges like ours. And I think that's enough. Yes. And be careful. So there's a dull side and there's a shiny side. I'm not gonna get into the complications of the dull and shiny side. So because that would take forever. The science already did take a while. So I'm gonna wind this in aluminum. Okay, we're gonna put the shiny side on top. And then we're gonna continue with the experiment. Why? Now my sister Hannah's gonna pour some baking soda into this bowl. Also, this is the same kind of baking soda from the baking soda and vinegar reaction. If you're unfamiliar, I bet you're familiar. Isn't that enough? No, there's no more. So you add vinegar with baking soda and you get a spoon. You would add only 1 teaspoon of baking soda, or sometimes 2 if you need more, or the reaction's fizzing. We might need to add more vinegar if the reaction is also fizzing. And it cleans other metal, but we're not doing that right now. And there's plenty of tutorials online, and I bet you know how to do it anyway. So I'm gonna put a little bit of iodized salt in there, and my brother David is gonna do that.
Dude, so I'm just not gonna pay a lot, just for you in react.
Yeah. So I'm gonna take a small amount of aluminum foil, and to give it better effects, I'm going to get a little bit more here, and I'm gonna tear it up. So I'm gonna make a small little ball. Make sure it has a lot of pores in there. Don't smash it super hard. Like, you know those aluminum foil balls challenges when you try to make them perfect? Don't do that. Just make it like this. It doesn't have to be round. And now we're gonna be preparing our hot water. So there's actually water in it. So now my sister Hannah's gonna turn on the button before I do. It's gonna get hot in a little bit. And me and the David later is gonna stir it with this thing. Indeed. Because I'm gonna go next. Please do. So now each one of us is going to take some silver jewelry and we're going to put it in the silver bowl. David. As soon as the water gets boiled and you hear a ding, and that thing will come up, Hannah will pour the water in there and I'll be mixing it. Remember, we're going to expect the sulfur gas and the rotten egg smell. So be prepared to not be, well, surprised by the smell. And Hannah, look at the steam. I'm not sure if you can see it by camera.
And now, Hannah, mix it when it's done.
Told you, that's the sound I'm talking about. Hannah, it's done.
Hannah, it's done. Hannah, it's done.
Hannah, it's going to turn off. Pick it up carefully, it might be heavy, and pour it in. It smells. It smells like rotten eggs. Yeah, that smell.
I don't even know how rotten eggs even smell.
It'll smell more later, you'll see.
Hannah, don't wait. That's enough. Hannah, no, that's
Come
enough.
closer to the bowl, you might smell it more there.
I do not smell it.
It does not smell good. David, I don't think the chemical is harmful to your body, so it just might smell. It just smells bad. Yeah. See, the tarnish is already coming off. It also smells a little bit like a jacuzzi. Don't know why. Maybe because of all the baking soda. Maybe that is silver, but not that pure. It did seem to go better. I keep the aluminum foil in. See, the aluminum foil is getting slightly more tarnished. And you're flipping them more than one time. Yeah, but they can't pick up that. How about we have more water? Or baking soda? Yeah, go smell it. So this is very interesting.
So now I'm gonna show how clean it is. Now it's not the most clean.
Hannah,
It's ready. You see that? It's much cleaner than it was, right? But we're gonna add some minute boiling water right there. So
right now,
because it's not
because
enough.
the reaction, we didn't get
A lot.
we got a lot of it, but we didn't get everything. So we're gonna try adding more water and see if it works. Be careful.
And
It's like dissolving more of the baking soda, but I don't see that much more reaction. But I do smell a lot more of the gas, which means the reaction is working. And I can't see all the fizzing. Yeah, I can totally see the baking soda disappearing. And look at how tarnished the foil is. Doesn't look that tarnished, but trust me, it is tarnished.
so like now,
You see how shiny it is?
yeah, look.
And the water's hot, so you might want to be careful with doing this kind of stuff. Fine. It's also, I'm good. It just startled me. It's also, it looks like it cleans the gems with the jewelry too a little bit. Or maybe the gems were just that clean in the first place. I don't know. But that's my hypothesis. My prediction. Remember how black this was?
Now look at it. Now it's good. I'll take that out so each part of it gets to be good. Yeah, Mom.
Now we're going to take some more jewelry and take a look at the results. Wait, Anna, why'd you do all of it? And didn't leave any for us? Yeah,
So,
you're splashing hot water.
yes, Anna, that is enough. Now peach.
We'll have to do one necklace at a time. Or one thing at a time.
Okay, that's all of it.
I guess we're not it. Okay. Anna's saying pass. Or that's at least looks like yes. Yeah, this is not tied. This is not it. I don't have a choice. So I'm gonna count that as so I'm not gonna do it anymore. Because this is just all too knotted. I'm not sure if it's too hot to touch. No, it's not hot. I mean, it's hot, but it's not boiling.
Yeah, it's not very hot.
Yeah.
This bit is less hot than
So
that.
it looks like I have to wash this with fresh water after we finish the experiment.
Hannah, when I'm going to leave something.
It turned out quite nice. This looks like it turned out to be only a small amount of silver, like I thought. But all the rest was not much better. See how, remember how this is not perfect though. You see, some of the still contains part of it. Why are you splashing this? Why are you putting it back? We just took all the silver onto a paper towel, and look how clean it is. Yes, we'll be doing a second round. Because it still does contain some tarnish on it. Because there's so much tarnish, it couldn't dissolve all of it. And this looks very, very full of stuff. And to us, it looks a lot like soup. But Dad asked us not to say this. Because Dad doesn't like jokes in the video. But I say otherwise. Look at how pretty these are. Let's imagine these going on Hannah. Hannah doesn't want to imagine.
Let's imagine these going on me.
No, let's imagine you wearing this.
Let's imagine me acting.
Oh yeah. The necklace itself,
Dad,
you
can
have
I
to open and close it.
Why?
But anyway. So, round one was a huge success, but we have to do it again because we didn't remove all of it. So I'm going to send the jewelry through a second round of cleaning. And look how tarnished this balls are. They're even more tarnished than this. So, what I'm actually planning on doing is I'm not going to take this off because there's no point in taking it off. What I'm planning on doing instead is adding more. So this time, I'm planning on adding more baking soda once the reaction fizzles down, since I realized that may help. I'm going to be adding some baking soda. So, to make most of my time, I'm going to turn on the hot water now, so that by the time I actually pour the soda in and get the aluminum balls, we'll be closer to ready. So here I'm going to take about this amount, and I'm going to make it into balls. Not quite exactly. So here I'm going to maximize surface area, and what I'm going to do it is I'm going to do it like this. And now I gotta add a little bit of salt. No way. So now it's ready, and I'm gonna put the silver jewelry in there, and then I'm gonna pour the boiling water in there. I'm gonna wait for it to boil again. I'm gonna take some salt and baking soda from down there. Now it's ready. I'm gonna add. I think that's. I'm gonna mix it really. It's a little bit hard with so much of this aluminum balls, but I can still try. And it smells a lot. So I'm gonna try getting some of the salt that I spilled back in there. Now let's see some of the jewelry. Looks very nice. And look how nice this looks in all this jewelry. I'm struggling to pick it up, but once I pick a piece up, you'll see that. See what I mean? And also, it smells more like eggs, doesn't smell like rotten eggs. To clarify. And be careful, do not splash water, especially if it's boiling. And if you're asking, those are earrings. So now I'm going to try to add a little bit of baking soda to see if it would spice up the reaction a little bit. I'm just going to add a small bit to test. It's producing more bubbles, you see. So I'm going to add a little bit more than that, a little bit more. See, with the reaction. You see, it's doing more. I poured all my baking soda in there. So now, I'm going to try to pour a little bit more of hot water, since what activates the baking soda is hot water. Yeah, so I'm going to turn it on. Oh yeah, we don't have enough water. It says, oh no, we're less than the minimum. This reaction is not like a salt and vinegar. We don't need any heat. The heat will activate the baking soda and cause it to work. As you can see here. So I'm gonna pour here a little bit more. And see it's fizzing more? And there's no more water in the tea kettle right now. So we're gonna take out more water if we want this reaction to continue. But right now this bowl's kind of full. And now since the water is hot, so now we're gonna take it out and we're gonna look at our results. It's easier to get that out too, even though it's not jewelry. Wow, look at how clean this is. But also the jewelry is kind of tied up in a knot again. There's still more. And this one's a little less milky. So, I mean, you can see it now. It looks less like a soup. So the tarnish is. So it's causing all this color. So it looks like we got everything. So this is actually passed. Let's see. Sure. We just finished our second round. And look how much cleaner this all is. The silver's so shiny and clean now. You know what else? You know those old silver chains that that people get at the garage sales? They're worth very little because they're tarnished and because they don't look that appealing. Because a lot of people don't know how to clean tarnish. But now you do, don't you? And now when you have this first, you might want to keep this since it's now nice and pretty. This chain looks very similar to mine, and look how clean it is. I wanted to see something. I want to see what all silver has as an international stamp. So, let's see. It says 925 Italy. So that means it's sterling silver. And it's made in Italy. All silver has a clasp saying what it is and where it's made. Somewhere. Normally, if it's for necklaces, it would be there. So I'm looking at the clasp to see what it says on it. So, yes. I think it's easier if I put it there. So. Look at how clean our chains turn out. So this one I couldn't identify. I wanted to see this one. So look at how awesome our grandmother's jewelry is. And also this one does say 95. So now I'm using chemistry to clean my grandmother's jewelry. Silver jewelry. We got very exciting these silver chains. Thanks to my dad for teaching me all this chemistry, filming, and helping make this channel and video possible. And thank you for watching. And don't forget to like and subscribe. And bye.